Okay, Christmas colors continue. Here we're going to integrate the error function ERF of x. And last time we saw that the ERF of x is just 2 over square root pi times the integral from 0 to x of e to the negative t squared dt. Therefore, this is pretty much an integral in itself, not an integral. How can we do this then? Well, now we have this as our new function. In fact, we can do this, and the answer will be in terms of the ERF of x. And last time we saw that we can actually differentiate this. Therefore, why don't we try to do this by integration by parts? Because remember, to do the integration by parts, we do one part to be differentiated and the other part to be integrated, right? Then therefore, let's go ahead and do that. And of course, I'll do the DI setup, the DI format, the DI method. So put on the D and I and put on plus minus on the side to get ready. I will be differentiating the ERF of x because if I put this right here, I'm pretty much doing the same original question. No good. I want to integrate just one. And now let's see, when I differentiate ERF of x, you pretty much look at this and differentiate that. And by fundamental theorem of calculus part 1, I can just put the x right here. That's pretty much it. And this is a constant multiple, so I'll just write this down. 2 over square root of pi times, no more integral because the derivative and integral cancel each other out pretty much, and put the x right here. So you have e to the negative x squared, and that's it. And to integrate 1, you just pretty much get x. And now, of course, we can just go ahead and do this times this, and that will be the first part of our answer. Let me write down the x first though. So we are talking about this is equal to x times ERF of x. And then for the second integral, don't forget that we look at this row, right? And this right here is still an integral. The product of this is still an integral, and this is a minus, so it's negative. Let me just write that down. Integral, and of course, I can put down the x right here. And then we have the e to the negative x squared dx. And since this is just a constant multiple, let me put that in the front, which is 2 over square root of pi, like that. And in fact, depends on how you want to do it. You can just do this in your head pretty much. This is totally doable now, right? So if you look at this, if you put a 2 right here instead, you have 1 like this. You see, the derivative of negative x squared is negative 2x. In fact, you have the negative 2x right here as well. So all in all, you pretty much can just do this by u sub, letting u equal to negative x squared. And the first part of the answer stays the same. So let me just write that down. But this is going to be cancelled after you do the u sub. So you pretty much will have this part by itself. So you have plus, right? And then you have that 1 over square root of pi e to the negative x squared, just like that, and we are done. And once again, if you differentiate this guy, this right here stays, and then this right here stays, but the chain rule says we have to multiply by the derivative of negative x squared, which is negative 2x right here. So that's why this right here is the answer, and we are done. Yeah, really nice, huh? Yeah, that's it. Hello, let's do some math for fun. Here we are going to find a solution to the equation e to the x that's equal to ln x. And you can expect that the answer to this right here is not real, because if you graph ln x and e to the x, you will see that e to the x